Hi YouTube, Wes Stampley here, JWS Repair Service. Today we're going to continue our series on the Polaris 500 motor. This also applies to 425s. You'll find the 500 motor in many models of Polarises, from four-wheelers to Rangers. Very common engine, and these are some of the common issues you may have with one. Now today we're going to be rebuilding the bottom end of the engine, so the crankshaft. We're going to replace the water pump, which was the cause of the failure, and I will show you what a damaged water pump looks like. We'll also be timing up the counterbalance and putting a button up the bottom end. So stay tuned and we'll be right back with that. Okay, here we are. As you can see, I've already got the crankcase split, the crankshaft's removed, the counterbalance is removed, the oil pump's removed. And it's important to note that you're going to build this from the left side of the crankcase. So it sits in the machine like this. This particular one came out of a 2009 Polaris Ranger EFI. It's going to sit in the machine like this. So this is the left-hand side, or the side that your belt drive would be on. So you're going to build everything from this side. So I've already removed everything, cleaned it, cleaned the gasket surfaces, and I'm ready to start reassembly and timing up the counterbalance and replacing the oil pump. So let me grab the crankshaft and counterbalance. I did replace this seal. I put just a little bit of oil on it so that it's not dry. And we're going to kind of start our crankshaft in here, but we need to get it lined up with the mark that's on the balancer gear. You've got a dot right. I'll try to show this to you. There is a dot right there. There is a dot on this crank gear right there. So we're going to mesh those together so that we don't, sorry, I'm looking at a, you've got a great angle, I've got a terrible one. So we're going to mesh these together and slide those in. Because if you put the crankshaft in all the way first, you won't be able to get the balancer in. So we're going to start this here and here. Well, actually I'm going to have to walk this double bearing in just a little bit more. It's not wanting to cooperate right this second. There we go. Let's get this started in. I'm going to wiggle that. Now we may have to give it just a little bit of love to get it to pull all the way, or to go all the way in there, but you should be able to kind of wiggle it and get it all the way in. So now we're going to, since that's not all the way in, we should still be able to get our balancer in here. Where is the dot? I don't see the dot from this angle. There it is. There we go. We're going to start that in the bearing. And there we go. And I was able to get that to slide almost all the way in there. There it goes. Okay, so the crankshaft is all the way in. You can see this together. There's very little gap here on this side. So that crankshaft is all the way in there, and our gears are flush right here. So that's how you know that it's in all the way. Double check the marks. You can see that the marks line up. Let me zoom that in just a bit. And you will see the marks there. And that's all there is to timing that up. Now there is a spacer here. Let me zoom back out. When you take these apart, they will have shimmed this, or they may or may not have shimmed this from the factory. Be sure not to lose these and put them back in the exact spots that they came in. Now on this one they did shim both the crankshaft and the counterbalancer shaft. You can see this one here. Sometimes they do, sometimes they don't. It just depends on what they find as far as clearances go when they're building the engines. So just be aware that if those come off, you need to put them back where they belong, and don't leave them out, or you're going to get some knocking in there from things shifting back and forth that shouldn't. So we've got the crankshaft and the counterbalance in. We're going to install a new water pump, but hang on just a second, let me grab the old pump and show you what the failure was. Okay, we're back. This is the oil pump. This is a disassembled or exploded view. I will tell you that you purchase these as an assembly from Polaris, so you would never really need to take this apart because they don't sell any of these internal parts because they're precision machined together. The times that you would want to replace this oil pump, now this is the oil pump shaft, but it's also the shaft for the water pump that goes through the water pump seal. And in a previous video we replaced the water pump seal. As you can see on this, if you look closely, there's a tremendous amount of wear, including a pretty substantial groove that is worn into this shaft. So if you had a water pump seal that just kept leaking even after you replace the mechanical seals and whatever, it may be that the shaft is worn. That would require a replacement of the oil pump, as this shaft is not sold by itself. It comes with the oil pump assembly from Polaris, so keep that in mind. Other than and mind you, even with this wear, the water pump didn't leak, but the engine was making a tremendous amount of noise because the oil pump itself had failed. Probably most likely due to water intrusion. The machine does have a snorkel kit on it, and typically when people put snorkel kits on them, they try to make them into submarines. They're not submarines, but hey, they do what they do. As long as they don't complain about the price when it's broken, I don't care. Now, this has a tremendous amount of grooves in it. Now, oil pump is always running in oil unless it doesn't have any oil in it. This one had a tremendous amount of oil in it because it wasn't ever leaving the oil tank. Polaris uses a dry sump system on this, so you have a two-stage pump. You have the larger side, which is this side, that here's your oil pickup, where there would be a screen here, but I've taken it off. You would have a large ring, or this is called a gear rotor type oil pump. A large gear with a smaller gear fitting inside it, and the shaft going up through it, and a pin dropping in and driving these gears. Now, like I said, these are always submerged in oil. They should never have a lot of wear on them. These have a tremendous amount of grooves in them. This won't work that way. What's happening is basically your scavenge side, which is what pulls oil up to help return it to the tank. The scavenge side's not scavenging the oil out of the engine. And then this thin side, this narrow side, this is your high pressure feed pump. This is scored. These should be perfectly smooth, and I know you can't see it in the pictures, but this is so sharp you can just about shave with it. So something caused this oil pump to at least run dry for a few moments, and when it did that, it just scored these parts beyond repair. So then there is, like I said, there is no repair on it. They don't sell pieces to it. So anyway, that is what caused the damage in the engine, and we'll show you that damage here as I'm building it back. So let me get my engine back, get the new oil pump ready to install, and we'll show you that. Be right back. Okay, we are back. I have the engine bottom end back in with the crankshaft and the counterbalance assembly that's timed up. Now here is the new oil pump. You'll notice they changed the style of the strainer on it. I don't know why, but they did, but it looks a little bit different. Here is the new pump face, and what we're going to do is just put just a tiny bit of oil, of engine oil, into this hole right here. Doesn't have to be a lot because it's going to drain out anyway. We're just going to turn that and let that pull that oil into those rotors so that they aren't starting up dry. But you don't want to use any kind of assembly grease or anything like that in your oil pump. Engine oil only. Very, very important. Now, that's got that through there so that our pump will prime up quickly when we get the engine back in. We're going to just put some motor oil on the sealing surface. There's no gasket here, no sealer. Very important. Do not put sealer on this. You may block an oil passage. I had a little bit of dirt on my finger there. Okay, make sure you don't have dirt on your finger either. That's not a good thing. All right, put that back in there. We're going to put just a little bit. Let me Zoom out some. We're going to put some oil on the sealing surface where this pump will sit. Let me move this a little bit more into the shot. We're going to put that there, and then we're going to take our oil pump and reinstall it. Now this part of the shaft is going to go just into a blind hole here. So it's just, there's no bearing there. It's just going to sit there. We're going to take this, align it. We'll take our bolts, screw those back in. They're just 3 bolts that mount the pump. And we're going to torque those down. Now I would say that these are torqued down snug, but because this is a DIY video, we try to do things right. I'll give you the actual torque specifications. The torque specifications per the Polaris manual are 62 to 80 inch-pounds, not foot-pounds, inch-pounds. I'm going to set my torque wrench at 70 just to kind of split the difference. 71 would be the actual dead center middle of it, but we're going to set it at 70 just for giggles. They're 10 millimeter. There's not really a torque pattern because you can't crisscross. It's only got 3, so there's a torque there. And I'm going to say this is just a kind of a snug hand tight. That's really not a tremendous amount of torque there. It's just, in lack of a better term, I just call it snug, but that's the actual specification for it. And then as far as the drive gear, let me clean the dirt off of this. As far as the drive gear for the oil pump goes, there's no need to time it. It doesn't have anything that it's doing at any specific time. It's pumping oil all the time. So we're just going to line up this pin with this hole in the gear. Pretty self-explanatory there, and just slide that on until it's all the way. That's that part of it. Now we're going to set this to the side. We'll take the other half of the crankcase. This is, once again, it's been cleaned. The gasket surfaces are clean, and we're going to get, I use personally, I used to use case sealant, specialized case sealant and stuff like that. But since silicons and RTVs especially have gotten so much better, I've just been using that, and it works just fine. Back in the day when I first got into this business, you had to use a specific case sealer because, well, frankly, the silicone stuff left a lot to be desired. Of course, it was right above me on the shelf, but I didn't see it. But this is Permatex Ultra Black. You don't want anything that hardens. You want something that'll stay semi-soft, so that's even what Polaris calls for. So they want you to use a gasket maker that doesn't harden. So that's why I prefer to use this stuff. And then you just want a light coating. You don't need a tremendous amount in here. Anything that you put in here, because this is a precision surface between the case halves, any extra excess material you put in here is going to get squeezed either inside or outside of the crankcase. That can get loose inside there if it goes inside the crankcase, and can stop up things like oil pump pickups, oil passages, water passages if there were any, but this doesn't have water passages right here, but on other stuff. So just keep in mind, you know, a little bit goes a long way on this, so it's going to be forced out somewhere. So we'll get that all the way around. And said just a light coating so that you can tell that it has some everywhere, and that will suffice. We're not going to put sealer on this because that is an oil crossover. We don't want anything in that might prevent that. It's just letting oil drain from one side of the crankcase to the other so it doesn't trap anything. So it's not really doing anything much anyway, but we don't want to block it because it's only basically just gravity feed. So there we go. We've got that on there. And we're ready to put the cases together. So simple as it sounds, we're going to take this half of the case and we're going to carefully place it on this half of the case. We're going to need to line up that water pump shaft. It's going to come through here. I can't see it, but it's on the oil pump, of course. There it is. Now I can see it coming through. You just want to be kind of gentle with that. Make sure you get that lined up. Everything else will pretty much fall into place. We may end up having to kind of give this a little bit of a love tap with a hammer, with a mallet rather, to get it to actually sit in, because this bearing is a lot tighter on the crankshaft. The other bearings are already, this bearing is actually going onto the crankshaft. The other bearings were on the crankshaft. We were just sliding it into the case, so that's the difference. So yeah, we just want to make sure we got everything lined up properly before we smack it. I like to try to get them as far as I possibly can so that I'm not having to just, you know, beat the hell out of it trying to get it together. Sometimes things are in a bind is why it won't go together, and if you try to just bash it together, you may damage something. So we're going to take this easy. It looks like we're just stuck on the bearing itself. So let me get my mallet. We're going to tap that together. Okay. I use a dead blow, not a metal hammer. We don't want to mar the surfaces of anything, so just use a mallet. If you don't have a mallet, use a piece of wood, preferably a hardwood that doesn't flake off and chip off while you're trying to put it together, and then you end up with wood inside the engine. Okay, you'll see once we got to a certain point, it just dropped together. So it doesn't, I wasn't hitting that very hard. You don't have to hit it very hard. If you're having to hit it very hard, something's wrong. So now we can test our operation to make sure everything's right before we actually bolt the case together. So I'm turning the crankshaft. The counterbalance is turning. If you can see through these holes in here, you'll see the gears turning. And our water pump shaft and oil pump shaft are turning. So that's what we needed to make sure that everything is turning. That lets us know that the gears are aligned and where they need to be. So now we're going to get the crankcase bolts and we're going to tighten those up and torque those as well. I will be right back. Okay, we're ready to install our case bolts, and I have them all here. I believe they are all the same length. Oh, no, they are not. Or that's not a case bolt. Let's see. Because I believe they're all identical, so yeah, that looks good. Okay, we'll go ahead, dip the thread in some motor oil. We're going to put those in the holes. The reason for the motor oil on the thread is that these are going to be torqued, and we want to make sure that we're getting a good accurate torque reading and not just a bolt that doesn't want to turn in a hole that is, you know, kind of dry or rusty. So I mean, you shouldn't have rust on aluminum, but you'll have rust from the steel bolts that were in it. But let me just put a little oil on that. You should do that with anything that you torque, as a matter of fact. It's just a good way to prevent an inaccurate torque reading because of corrosion. So we're going to get all these bolts in there, and we're going to just slightly bottom these just to get them ready to go in, and we'll torque them. Actually, I'm going to take this, I'm going to swap these two. That one was outside the cover. As you can tell, this one is nice and clean on top, and that one had dirt and stuff on it. So we'll put the clean ones back where they belong. No, it doesn't make any difference, same bolt, but just cause. So we'll finger all these down, and then I'm going to go ahead and pause it here, and I will be back for the torque process. Okay, we're back. I've got these bolts just taken down. They're not tight. I just brought them all down to where they're just touching the case so that I haven't torqued anything yet. Now, per the manual, Polaris wants these tightened in a crisscross pattern to 14 to 15 foot-pounds. Now, my torque wrench will go down to 15 pounds, but I don't really feel that it's very accurate on a foot-pound gauge. So what I did was just convert that to inch-pounds, because I think it'll give us a better, more accurate reading. So the inch-pounds for, I like to split the difference too when they give me a range. So 14 to 15, 14 and a half inch-pounds would be 170, or excuse me, 14 and a half foot-pounds would be 174 inch-pounds. So that's what I've set my torque wrench to, and we're going to go ahead and torque these down. And that's, once again, fairly snug, but not just crazy tight. So not that difficult to do. But I'm going to start at the center and move my way out, and as crisscross as I can get with something that's not a standard shape. It's asymmetrical, so it's kind of hard to do an actual crisscross, but nevertheless, that's what the manual says, so we'll go with that. But I don't have any opposite on this side, so I'm just going to have to tighten these up. But if you just start from the inner and from the inside, torque these opposite of each other. That's the main thing. That's the most important part. So start from the inside, torque those in a cross pattern, and then work your way out. You'll be fine. Okay, we're just going to go around and confirm that I didn't miss any. And I don't know if you kept up with the count on that, of how many bolts it was. I just know it was a lot. It was about a few. You can comment in the comments and tell me what the actual count was. That'd be great, because frankly I didn't even pay attention. But that will put the majority of our bottom end together, except for the gears that go on the crankshaft. So we're going to do that. We'll go ahead and put the water pump impeller in and that. So let me grab those items and I'll be right back. Okay, we're back, and I'm going to show you the main cause of the failure with this engine. Like I said, it came in running, but it had a tremendous amount of noise in it. I'm going to show you, I'm going to zoom in. This is the gear that sits on the crankshaft that drives the cam chain. Now this is the one that came off of it, and this is what it should look like. You'll see there aren't many teeth on this at all. I'm shocked that this engine was running in the least. It had jump time a bit, but not enough for it to actually stop running, believe it or not. But the valves had tapped the piston. They weren't necessarily bent, but when I did do a video on the top end of doing the valve job on it, which if you look through my videos, I'll try to remember to leave the link in the description here if you want to look at that. But when I did the valve job, it did appear that one of the intake valves had been bent, but just not enough that it had lost compression where it couldn't run. But this was the main source of the failure due to the water pump losing pressure. The oil pump losing pressure. It starved the engine of oil, especially under this cover, which is where this gear resides. And it's chained because this is already a restricted passage. They don't need a whole lot of oil to go in here. So when it lost oil pressure, this went dry. And once it did that, it just started eating stuff up. So you could see it just absolutely destroyed that gear. And like I said, there's really no comparison there. Now, I don't have the Polaris number for this. You can see this is a Polaris part, but I buy it through a dealer-only network, so they covered up the part number, the Polaris part number, but it should be the same for pretty much anything. But like I said, this is and this 335, 400, forget that. That doesn't apply to this. Don't worry about this. Just get the one from Polaris. It'll fit your machine. But we're going to take that. There is a just a straight key here that we're going to line up and slide that gear down on. Now this gear is held on by this silly looking little nut that they call this a spanner nut. They do make special spanner sockets that will grab these edges on it and tighten them up. If we had one for every one of these nuts we see on a daily basis, we'd have about 500 of them. So nevertheless, they don't have to be super duper tight. It is a left hand thread, by the way, so the way it seems that you're loosening it is the way you're going to tighten it. But it's easy enough just to get a chisel, grab on one of the flats there, give it a couple of smacks. It doesn't have to be ridiculously tight, so you can get away with this. At least you can get to that. Now some things that use spanners, we actually do have the tools for, because you can't get anything in there to them, because the specific reason of it being a round nut like that is because it's fitting inside something, and there's no room to have a socket where you can put on the outside. They could have put this on the outside, they just didn't. Or they could have used just a regular hex nut, but they didn't. But you know, I don't know. I can't go by what they design stuff. All I can do is put it back together. So let me grab my hammer here. I'm going to run the crankshaft down, and what I'm going to do is put a long extension through that, and then we're going to turn it around to where that holds tight. We're going to take this, and we want to make sure there's no slack in the where I'm got the rod set up. We don't want any slack there. We want it to be pulling back. We don't want to damage anything here. This is a little sketch, but not too bad. As long as you're careful and you're just holding the crankshaft stationary, you're not going to hurt anything. But you don't want that bouncing back and forth with each hammer blower. You could definitely damage something. And that's probably mucho tight enough. And there we go. It doesn't, like I said, it doesn't have to be extremely tight. It's already a left-hand thread, so its tendency is going to want to be tighter. So no need to just wail on it. Now we will install the water pump impeller. That's this little guy, just like that. And then the water pump nut. That is not a left-hand thread on that. However, I did notice that on this brand new oil pump shaft there was a little bit of a burr on the end of it, which was a little disappointing, but it kind of makes that nut a little bit more difficult to get on there than it should be. But I'm going to hold the crankshaft so I can tighten this down. And the torque on this water pump impeller is snug. I didn't find an actual spec for how tight they wanted that impeller nut. So yeah, just get it good and snug, you'll be fine. Okay, that's pretty tight. I'm just holding the rod up here with my fingers, so yeah, that's about as tight as I can get it and hold on to it, so that'll be fine. Now you can see everything turning together. Turn this up on its side, make it a little bit easier to get a hold of, but that's everything turning together. You can see your water pump's going. Well, no you can't because I moved it too far. I'm just turning this by hand using the rod, just like the engine would do it, and that's pretty smooth. Now you can definitely hear the gears running together because it's dry in there, but it won't be that way when it's running. So, alright, we'll set that up. We're going to put the stator back in it and the cover for the water pump, but first we're going to get the cam chain tensioners back in. Not this one so much as this one, because this one you can see is the stator plate is going to fit over this. So we've got to get the cam chain in there and this cam chain guide in there before we do anything else. So let me grab those items and I'll be right back. Okay, I'm back. This is the one guide that we need to install right now. You can see that Polaris part number is a 3084917. The reason that we're installing it right now is because let me move it where you can see it. Where it's actually going to go is through the chain tunnel here into the bottom, and then it's got this pivot bolt that fits here, so we've got to put that in. Obviously it's below the stator, so there's no way that you would be able to get that if it was in there. So let me grab a socket and we will tighten that up. Once again, this is going to be another one of those that didn't actually have a spec, so it's going to be snug. We're just going to tighten it to where it feels good. And I'd say, yeah, that feels good right there. Make sure that it pivots freely. Now the other guide we don't have to put in right now because frankly it's not going to stay there. But this guide just sits here in this groove. We can put that in when we put the top end on, and that's going to be in the next video that we do the top end. So anyway, for right now we're not going to worry about this. And if you look closely here, this is a good time to point this out. If you look closely here, you'll see some of the damage to these surfaces that was caused by the cam chain bouncing around in there. You can see the grooving that is on this section here. You can also see where it took a chunk out of the case here, there, and it also did it further up in here too, where that chain was just really slapping around. If you look at it from this angle, if I can get everything in the right spot, if you look at it from this angle, you can see this section right here. It looks like it's polished. It's actually where the chain was going side to side because it was so stretched. It was actually grinding the side of the case. So yes, it was making a tremendous amount of noise. There was no doubt the customer wasn't fully aware that something wasn't right, but nevertheless, it came in with no mention of a tremendous amount of engine noise. I guess if they didn't tell us about it, it would make it less expensive to fix. Unfortunately, it didn't work that way. Now this stationary slider, part number 3084916. So you want to see that once again. Okay, and like I said, we're not going to put that in right now. Here is the new cam chain. This is actually an aftermarket cam chain. Polaris doesn't make their own cam chains, neither do most manufacturers. So I get this from that same supplier that I get the other my other factory parts, but this was actually an aftermarket chain, so it should do me any good to show you the part number on that because you can't buy directly from them. You have to be a dealer. So we're going to put the cam chain on just like that. We'll let that slide and fall over. Now we can put our stator back in. And it's going to fit in over all of that stuff. It's got, it has an O-ring on it. Make sure it's on there. And actually, while I'm doing that, I probably ought to put just a little bit of oil on this O-ring and this one. This is just a drain back hole for any oil, excess oil that gets up here under this. There's not any active oiling in this chamber. It's really just what splashes around and what gravity brings in. So it's just got a couple of drains on it to get that back. But anyway, we're going to go ahead and make sure we oil that O-ring so it'll sit down in here nicely. Put our grommet back in, line up the bolt holes, and then get this to slide down into that groove, because it's making me compress that O-ring, so that's making it a little tight. Come on, baby. I just pulled the dang chain off. Whoopsie. Be careful with that chain. If you're monkeying around in here, you can lose that chain. Let's not do that. We want that to stay on. Because once I put that alternator in there, we're not going to be able to see that to put it back on. So we need that to stay there. Okay. Okay, let's give this a little bit of a tap. I don't want to hit the stator itself. I'm going to tap the outside cover. And get that O-ring to seat. A little snug, as you might be able to notice there. Alright. But yeah, we can still turn it. But it's you got to, it wants to compress that O-ring down inside there. So let's get our stator bolts. Now we will run these down. And once again, the torque on this is going to be just tight, just snug. Not a big deal, really. Some stuff is very, very critical on torque. The majority of stuff like this is not. You're just literally mounting the thing. So as long as you get it where it's, you know, fairly snug, you're okay. No torque required. But things like cam caps, head bolts, cylinder bolts, things like that, those are pretty important. So yeah, we need to make sure we torque stuff like that. But this just needs to be tight. Now there may be a torque spec on this now that I think about it, but it really doesn't matter. It just needs to be good and snug. Okay, that gets that in, that gets our chain in, our bottom end is back together. The stator's in it. The only thing we need to do is install the flywheel, the starter drive, then the flywheel. Very important. It's in that order. So I will be right back after I get those items cleaned up. Okay, now we'll install the water pump impeller right there. There's a little sealing washer. Now yours may or may not have had a washer underneath this. It varies by application. So if it had one, put it back in there. If it didn't, don't worry about it. But you do need the sealing washer on top. Now we're going to tighten the nut up, and this will once again be just snug. I like to get these fairly tight, but you're going to have to hold the crankshaft to keep it from turning. So just get her snug. Ow! So I'm going to hold the crank. Alright, that's good and tight, and that'll stay on there. Alright, now we're going to install the water pump cover. I've cleaned it. They sometimes have a gasket, sometimes they don't. So this one did not, so we're going to put sealer on it. Careful not to get any inside it. On this you can be a little more generous with the sealer if it did not have a gasket, or if you're eliminating the gasket. You can be a little more generous because it's got a little more room for it to squeeze out, but you just don't want too much on it because it's got to go somewhere. So we're going to get a nice bead of silicone around that. This alternator cover will also be sealer only. But for right now, we're just going to put the water pump cover on and install those screws. Now these have an 8mm head on them versus all the rest of them that were 10, except for that one movable chain tensioner that had a 12. But let me grab an 8 socket. And these, once again, just need to be good and snug. I mean, Polaris puts out a spec for just general 6mm, generic 6mm bolts. And I don't remember exactly what it is, but it's, I mean, just get them, you know, snug. They don't have to be, you don't want to kill it, but you want it to be tight. Like, you don't want it to be too loose or too tight. Just get it snug. And I've actually got a torque set up on this, and it's wow, running 120 inch-pounds, so 10 foot-pounds. But anyway, that's what I'm using for those. So as you can see, we've got a nice bead that it's squeezed out all the way around the cover, and that tells us that we got a good seal with the cover with the sealer, so that's a good thing. Okay, now we can install the flywheel key right here, if it'll go in like it's supposed to. May need some words of encouragement there. Come on, good little flywheel key, you can make it, you can do it. Or maybe give it a little love tap too. There we go, now it's in there. I'm going to take a chisel and just slightly seat this all the way down so it's flush. Alright, tighten that up. We're going to take now this has a washer on it. This is the starter drive. Don't lose the washer. Washer goes in there. We're going to take that and go ahead and put that in there, but I'm going to put just a little dollop of grease on the end of this. Not a whole bunch, just a little bit. Slide that in there. Now we're going to take our flywheel, make sure our key is lined up, and watch your fingers on this because the magnets are really strong and it's going to grab this flywheel and yank it down. So be aware of it's going to try to bite you. Come on, you can do it. There we go. Okay, then big washer, and then the flywheel nut. Now this does have a torque spec on it, and I'll be right. Okay, I've already torqued the nut down for the flywheel. It is 65 foot-pounds, so it's pretty stout, so it was impossible to be able to tighten this down and torque it by having somebody else help hold it and that up on this bench. So unfortunately I couldn't show you that, but I mean, tighten it to 65 foot-pounds, you're good. The actual spec is 58 to 72, and I just split the difference on it. So as far as it goes, we are finished with the bottom end. There's nothing else I can really put on it now. I mean, I could put this flywheel cover on, but I'm going to want to be able to turn the crankshaft while I'm putting the top end on it. So we're going to leave that off for now, but the only thing left to do to this is just literally put sealer on this and put this cover on. So we'll catch us in the next video and we'll do the top end. Thanks for watching. Appreciate you taking a look at this and learning a little bit about the bottom end on a Polaris 500. The next video will be installing the top end, the piston, cylinder, all that. So if you'd like to see that, just look on the channel and you'll see it. If you liked what you saw, please be sure to hit the like button. If you want to subscribe to our channel, please feel free to hit that button. It helps us build the channel. It's free to you, but it really helps us out. You can also hit that notification bell so you'll be the first one to know when a new video is posted. And as always, you can catch us on the web at www.jwsrepairservices.com. Thanks for watching. Have a good one.